Hello and welcome to part 3 of the Deluxe Wimshurst build. Kind of a tongue twister. Anyway, let's review what we've done so far. Okay, in part 2 we fitted the columns, fumed the oak with ammonia. Well, that turned out good. That's really going to come to life when we put oil on it. And we built these uprights, painted them, and I took the tape off them off camera. Those go right there. And I bought these rubber washers. They're same diameter as the bottom there, a little bit loose fitting on the bolt. But I already tested one. You put that on there and put a wing nut on the bottom and you can't turn it. It grabs. So that's what we want, because we're going to put a different kind of an electrode on here and we don't want these to be able to rotate. So, got a wing nut on the bottom. Today, we're going to start with the disc hubs and possibly put the discs on the hubs and put the sectors on the disc. It's fairly involved and you got to be really careful to get everything lined up right. Okay, here's what we're building next. It's a disc hub. It's made out of Delrin. You could make it out of wood, you could make it out of PVC, Delrin or Astel, or I don't know if I'm pronouncing that right. But it's about the cheapest in a plastic. But wood works really well too if you can make this surface very true to the axle. You almost have to have a metal lathe, because if you don't get that surface absolutely true, these discs will wobble quite a bit. So that's what we're doing now. Okay, each hub is 2.5 inches long. I'm going to cut it a 1/16 longer than what it needs to be. Delrin machine's really nice. I wish it had a better finish on it. I've tried to finish it before, and really I'm better off leaving it like it is. You might be able to paint it or put a clear finish on it. I don't know, but it looks good enough the way it is, and I'm just going to leave it. Okay, here's our future hub cut to approximate length. I'm going to leave this side as is and surface this side in the lathe and drill the hole on this side. Okay, the sequence of operation right here is fairly important, and I'll show you what I'm talking about. First, I want to face the end of that. I'm going to make these the same length. I think I can take it in one pass. So I'm going to lock the carriage. Okay, that's going to be our disc mounting surface. I'm going to drill that with a 1/2 inch drill. It's a 3/8 axle in the hubs, but I'm going to press a 1/2 inch OD bushing in there. And normally I would drill slightly undersized and ream it to the correct diameter. But if I remember right, this plastic drills on size or slightly under, and the bushing slips right in there. No pilot hole. There we are. Now, that surface is true to the axle, and that's very important. Okay, we're using a flanged sleeve bearing on the disc side, the side we just finished. And later we're going to push that sleeve bearing in without a flange, but I'm going to finish that surface before I do. Okay, I've got both pulleys faced and the bushing put in there. Now I'm going to flip them over. And I wasn't going to do this at first, but I think I'll dress dress up that end. Plus it's a little bit long. Okay, I've got a tool that I ground there. It's about 3/16 wide. And it's ground to fit this belt. That's a 4mm belt, plus a little bit. It's got a little bit of clearance there. And I want this, the center of this tool, 3/4 of an inch from the end, which is about where that is. Okay, let's make some discs. First we got to find the center. Get as close as you can to the center, because I'm starting with 18 by 18 discs, and they will end up being 17.5 to 17 3/4 inches in diameter. Okay, we've got the center marked, and I'm going to use this, a step drill, like they'd use for drilling through sheet metal. This is the best way to drill plexiglass. It will not shatter. Okay, this right here is 11/16, I think. Yeah, 11/16. And there's a step on here that's 11/16. And that's almost the maximum for this one. Of course, every one of these is going to be different. So I want to go to that last step. Okay. That will fit down in that hole. I think I went the right. I didn't go deep enough. It would be easy to go too far. Perfect. So there's one. We'll do both discs. Now, I made this drill guide. It's got a protrusion of 11/16 on one side and a recess of 11/16 on the other side. So, to drill the pilot holes in this side, you lay that on there, use it for a drill guide, and it's 1/8" drill. And I think a number 8 wood screw goes into the plastic really well. But then you flip it over and use it for a guide here. With the drill in there all the way in the chuck, that's plenty deep for a pilot hole. Deeper than necessary, but that's about how deep I'll go. Now there's a trick to this. Makes it a lot easier. You drill one, like that. And then you take another 1/8" drill and you put it in that hole, like that. Then you can drill your other 1/8" pilot holes and nothing will move. Now we take this drill guide and do the same with our disc right here. Now we're leaving this protective layer on there till the last minute because this stuff is easy to scratch. Okay, now we need to open up a clearance hole so that doesn't thread into the disc, but it only threads into the hub. Okay, I'm going to do something, and I'll explain why later. I'm going to drill a hole right here. Okay, the reason I drilled this hole on the corner is because I'm going to use it to establish my depth. If you have a drill press that's got a deep enough throat, you can do these by hand. But it's way easier to control the depth. Putting a countersink in there, it's way easier to control the depth if you got a drill press. That's not good enough. You want this screw to be flush, just barely under the surface. Oh, that's perfect. And when I did that, I had my depth stop snug so that when I drilled the appropriate depth, it stayed put. Now I've tightened it down where it'll stop my depth. Now I can drill all these holes to the appropriate depth. Now I flipped this over too. That step drill, sometimes, I don't know if you can see it, it left a little ledge right there that didn't go all the way through because each step isn't deep enough. So I've flipped this over so that when I put my hub on the plastic, it won't have that little ledge right there stopping it from going in. So this is flipped over from when we drilled the original holes. Okay, what we want to do right here, the countersinks are on the bottom side of this. We want to peel this plastic back in the center. That allows this to seat on the plastic. Don't want any dust in there. Those holes line up perfect. Now, the advantage to doing this is that bushing keeps the disc centered along with the screws. Perfect. There's also another advantage. There's a spacer that goes between these discs to maintain the space, and you can make a steel spacer and it'll go up against that brass bushing, or the flange on that brass bushing, bronze. Using a hand screwdriver is way easier. You can feel when it hits. You don't want that super tight because plastic will, over a period of time, it will crack if you get that too tight. So there's one disc. You don't have to do this, but trimming off some of the extra plastic before we make it round is a good thing. I swear I haven't been drinking. Okay, last time I made a disc, I used this piece of wood. And I've got this jig attached to my fence. So I can move my fence back and get closer to my bit. But my dust collection doesn't pick it up very good. The reason I did that is because I started from square. So I had to knock the corners off. So I'm going to move this pin into about there so that my dust collection will be closer to what I'm cutting. A hole right there. Of course, your router table is going to be different. And I used to just clamp a board to the surface of the table. I didn't connect it to the fence. I just kind of got fancy. Now I'm going to open up my dust collection port there, so hopefully get some of this mess out of here. This is real messy, or it was last time. Okay, let's look at what we're doing here. This bit is turning this way, so we want to go this way and cut that disc round. Now if you ever let that get away from you, that bit is going to drive that disc and probably chew up your hands with the edge of that disc. So don't do that. Always maintain firm control over the disc. Don't get carried away and get crazy with it. Yeah, let's make some noise. Well, hopefully it goes cleaner than last time. Okay, I've made a visual reference, and I'm going to make a mark right here. That's where I stop moving the fence in. So when I cut my next disc, hopefully I'll be close to that. Okay, here we go. Same diameter. Okay, we got to put 48 sectors on this disc. And I drew this in CAD and I used it on the last machine I built. Okay, the question in my mind is how to cut these sectors out. How to cut that foil sector out so they're all the same. What I'll do is lay that on there and peel and paste the sectors looking through the disc. First we got to have sectors. Well, I've been building these things for a while, and I made a little device to do that. It has a die in it, and it does what's called kiss cutting. I may have to adjust it a little bit. But it will cut through the foil and not the backing. It's got a couple of one-way needle bearings in there. So this acts like a ratchet, and this will only turn one direction. So let's demonstrate this. We need 48 of them per disc. So I need to go 1, 2, 3, 4, 5, 6, 7, 28, 29, 30. Hopefully this works. I have had trouble with it cutting through the foil adequately. It seems to be doing good now. Pretty sensitive adjustment there. I mean that foil's 3/1000 thick, I think. So there's one disc. I need 28 more. Okay, now we got to remove this backing on one side. And don't do like I did one time and paste the sectors on the protective film. I want to center that up on it. Looks pretty well centered, and then I'm going to tape it. Doesn't need much, but it's a good idea to tape it because it will move if you bump it. This sector template was made for a 17.5-inch disc, and I believe we got about 18 3/4 or 17 3/4. Yeah. So I'm going to fudge a little bit and paste them about an 1/8 inch out from that image. Now, you can get real critical about this. Like that one's off very slightly from the image below it. This way, you'll never see it. If you're off a 1/16 of an inch, it doesn't matter. Now there's a trick to peeling these things. Let me show you. I've got a piece of sheet metal clamped on my cutoff sled. And if you do like this, peels off. If you peel them off, the backing, they roll up on you. Here's what I'm doing now. That screw eye threads into the axle, and that's what holds the pulley to the axle. This is a gun tap, so I didn't have to back it up to clear the chips. It pushes the chips out the front. Not very good for a blind hole, but it works great for other holes. It's really not very critical here. But I gotta drill a pilot hole right there for that screw eye. I just wanted to get kind of form some threads in there. That's kind of hard to get in when it's in the machine. Okay, now we got to press in the sleeve bearings. And I wish I had some 3/4 inch sleeve bearings. I don't. I've got some shorter ones. I'm going to put 2 of them in, and that'll work just fine, but the 3/4 inch would be easier. Okay, these sleeve bearings get pressed into here, and they're a little loose. So I'm going to put them in part way. And it probably doesn't matter if they're loose. And I'll explain why in a minute, but I'm going to put them in part way and then put some super glue on the sides of them. And that super glue may not hold them. They're oil impregnated bearings, so who knows. The reason it really doesn't matter is because there's going to be a washer like that, and this will be underneath the Wimshurst and be nothing's going to push that bushing out. Okay, these little sleeve bearings are 3/16 inside. I got a 1024 here, and it doesn't go in there. Sometimes, some of them do and some of them don't. I don't know if there's, this is truer to dimension in here, but even these are a little oversized. So I've been taking them and putting them in the drill press and filing them off a little bit, threads and the shank. Doesn't take a whole lot, see there? There's plenty of threads there to hold still. Then I grip the threads gently. Too many things in my hand here. And do the same to the shank. The unthreaded portion, if you want to call it that. That's good. Okay, I believe I'm going to need about 3 washers in here to raise the level of that pulley up where it needs to be. And here's how this works. Put that through there like that. Put a 1024 nut on there, washer, and you want slop in that. That's okay. But what you want is this bolt going through there enough to where you can put this acorn nut on top and secure it. And there's not very many threads in the acorn, but plenty to secure it. Give you a little bit to tighten. Then I'll screw this into the base. Hopefully that nut won't move on the screw. Once it's through there, when you tighten the acorn nut on the top, that nut won't move. There we go. Excellent. Now I'll just tighten that, and that's, now there's a wide pulley or a large pulley and a small pulley. Got to do the same thing on this side. If I can find my, there it is. 3 washers, pulley, nut, washer. The hole in the base I drilled 3/16. So the threads kind of grab in the wood. Really not holding much, but it's a good snug fit, which is good. Okay, next step. Put the drive pulleys in. See, I'm not hitting the hole. Part of it may be where I'm not where that hole's not drilled exactly square, but I'm looking in the back here, and it looks like I can move my pylon or disc support column or whatever you want to call it this way. Yeah, still going to have to drill it out a little bit. No big deal. It's easy to drill out. You can do it with a drill or a reamer. Reamer gives you a little more control. I think it got a little bit of oil finish in there and got sticky. There we go. Okay. It's spinning good in there now. It's 5.5 inches from one end, and I don't remember what it is from the other to that hole right there. So the pulley with the hole, let's see, goes this way. In other words, that hole is going to be facing the back. Okay, who designed this thing anyway? I just keep forgetting stuff. Gotta have a lock collar in there. Second pulley, another lock collar. Now we're cooking. Now the screw eye. That hole needs to be fairly well centered in that screw eye, the hole in the pulley. You could put a hole all the way through and a couple of washers and a screw and a nut. Wood screw is plenty good though. Here we go. Coming along. Crank go right there. That's the drive pulley. This is an idler. Okay. These here are electrode and collector supports. And I got a rubber washer here. This is going to work really well, I think. That rubber washer goes right there. I wish it had a 1/4 inch hole. It's got a 5/16. Just center that there. And then wing nut on the bottom. Probably wouldn't hurt to put a washer on there. You could use a nut on the bottom actually. It might be a good idea. I don't know. Wing nut works good though, but it needs to stay tight and not rotate. Those are very solid. I like that. Probably wouldn't hurt to take a pair of pliers and tighten those. You don't want to get extremely tight though. You're tightening down on plastic, and it's got that fender washer inside, so it should be pretty strong, but you could conceivably break the plastic. But you don't want those electrode supports twisting. That looks pretty good right there. It feels solid. Okay, let's put the discs in there. Okay, before we put the discs in there, I need to put this screw in there. This threads into the wood again. Just helps it stay put there. It's not important that it threads into the wood, but it just keeps the screw in place. This will be to hold our neutralizer bars. Now I have had to grind the head of the screw down, the diameter of it, because I didn't get the hole positioned exactly right, and it tipped the screw down when it hit the bottom of that slot. But it looks like that's really straight, so I must have got it right this time. Okay, I've taken the plastic off both discs. I had the plastic off, obviously, where the sectors are applied, but I took it off the backside too. I've got a spacer I made. It's 3/8 wide and a little over 3/8 on the inside. That sits right there. And the neat thing about the way this is constructed, it's got a sleeve bearing with a flange on it. And that flange acts as a bearing against that spacer. A lot of people use like a felt washer or a cardboard washer between the discs, but this is way better. It lasts forever. Doesn't create any dust. Put the axle in there. There we go. Looks good. That noise will go away when the discs are under load. And there's oil in those bearings. It just has to get warm and it'll start lubricating. Now there's a certain amount of slop here. The reason I did that is to make up for irregularities. Quite often I'll put a washer on the shaft in there, like right there, just to stop that. It really, most of the time, doesn't hurt a thing. So, we're almost ready to put the drive belts on. The next step, and I could have done this before I put the discs on, but you can critically position the belt with the disc with those lock collars. I think I'll snug them down. It'll make them a little easier to put a belt on. They don't need to be tight, just take the play out. Now this pulley floats, and it's supposed to float. So the next step is to put the belt on. Okay, before we put this belt on, I'm going to put this cool crank on. Had these cranks made, darned expensive too. They're laser cut, and I made that knob on my CNC lathe. But that's you can see where it's got some imperfections in it and stuff, but the overall effect is pretty nice. Had to do a lot of grinding on it though to make it look like that. I don't know if it's worthwhile or not. Neat effect though. Okay, let's put the belt on. Let's talk a little bit about this belt. This is 4mm, and I've seen it online before. It's readily available. This particular belt is made by Habesset, which is a European country, or a European-made belt. And it's a good belt, but the cheaper imitations are just as good. It's polyurethane. I've heard it called poly round. I've heard it called poly cord, but it's a polyurethane belt. And it melts together. Now I've got a special iron for doing it. It was a fairly cheap iron, but I cannot find them anywhere now. This works just as well. This is a soldering iron. If you get one with a kind of a wide tip like that, the only thing is on a soldering iron, they get a little bit too hot. So you got to kind of catch it before it gets too hot. And you'll know it's too hot when you see the rubber bubbling when you're making the weld. So I've got this iron plugged in, but right now we're going to thread this belt through here and cut it to length. Now this is a confusing way to thread this. And can you see how that's working? Now go to the inner groove around this pulley. And coming off the small pulley goes to the inner groove of this drive pulley. Now I got to cut it to length. cut it to length, I forget, I wish I could remember, there's a certain percentage of stretch. In other words, you pull it snug and then stretch it. But I don't remember what that is. Plus, I don't know how many feet there are here. Quite a few, actually. I'm going to pull it about 1.5 inches and then cut it. It stretches over time also. So now we can take this belt off. Because it's fairly easy to thread once you get it in there. Right here I made a little wood block out of just an old 2x4. And it's better if it fits snug in there. I got it a little bit loose. But you just put it in there like that. Okay, what you want to do is put that iron between there and push on both belts until you see a bead form. And once you have a bead form, you just let it sit there without feeding more belt into it. So what you're doing is you're making the rubber soft down in the belt. So I'm going to do that. As there's a bead forming. Okay, I got a good bead. That means I got good contact. Let me zoom in and pardon the camera movement. I'm doing two things at once here. You can probably see the bead right there. And you leave it on there for about 10 to 15 seconds, maybe a little more. Pull it out and immediately push it together. Be better if that gap wasn't quite so wide. And when you push it together, don't push it together a bunch, because if you do, you're pushing all the molten rubber away and you end up with cold rubber against cold rubber. That's the biggest trick to making these splices. I wish that was aligned a little better, but just let that cool there for probably maybe 3 minutes. Okay, that's been about, I don't know, 4 minutes, I guess. Now, pull it out of the guide, and you take, you can also do it with a grinder, but clippers work good. Flush cutting trimmers. Just cut that bead off of there. If you make that splice right, theoretically that's the same strength as the rest of the belt. I'm not going to put it to the test, but it is very strong. Still a little warm anyway. Okay, let's thread this belt. The way you do this is you put the loop over the disc like this. Go to the wide pulley first underneath. The two outer slots on the it gets confusing. Okay, I'm on the two lower pulleys now, or was. Came off the back. That's the only place it's off. That's why it's getting tight. There we go. Are you totally confused? Now, let's take a closer look in here. This belt right here doesn't look straight. So, to get that straight, slide the pulley over a little like that. This back one's self-adjusting, but the front one is not. Looking good. The noise you hear will get better. You always hear a little bit, but it's where the bushings are breaking in. Pulleys are fairly well lined up on the bottom, going straight across. They got movement there. It could have been a little bit higher. I could have used three washers to support that pulley. Pretty darn close, so nobody will ever notice that. Those discs are running really true. Hardly any wobble to them. Usually there's a little more wobble than that. Wobble's not good, but if it wobbles 1/16 of an inch, not a problem. Even 1/8 of an inch is really not a problem. But this one's really true. Anyway, that about wraps up part 3. Part 4, we will be putting the electrodes on and the collectors and the neutralizer bars. Anyway, thanks for joining me, and be sure and subscribe and ring that bell. That way you'll be notified when part 4 comes out.